This is a Math 1 lesson summary video for the lesson titled Lies in Statistics. This is a practice understanding task. The purpose of this lesson is for students to refine their understanding of correlation coefficients, residuals, and linear regression. So in this video, I'm going to go over the vocabulary of linear regression, correlation coefficient, and residuals, and then we'll go to Desmos to work with some data. A linear regression equation is an equation that predicts the trend of the data. So here we have a line of best fit that is calculated with technology. With Desmos, to create a linear regression equation, you'll want to start by entering the data into a table. Pay attention to your variable labels. They'll most likely be x1, y1. If your variable labels are x1, y1, type y1 and then a tilde, mx1 plus b into the expression bar. You'll find that tilde on your keyboard if you push shift and the button right to the left of number 1. Often when you have linear regression equations, you'll use the slope and the y-intercept to better understand data and the relationship between the variables. Correlation coefficient is an R value, so R is the variable that's used. It's an R value between -1 and 1. If R is equal to -1, you have a perfect negative correlation. If R is equal to 1, you have a perfect positive correlation. If R is equal to 0, then there is no correlation. Positive correlation happens when one variable increases and the other is also increasing. So your line, your linear regression line, would have a positive slope. A negative correlation is when one variable increases and the other is decreasing. So this example is an example of negative correlation. On Desmos, enter the data into a table. Pay attention to the variable labels. They'll most likely be x1, y1. And in the expression bar, you can type CORR and then parentheses x1, y1. Your other option is when you're calculating linear regression, it'll be listed right here. It's also important to remember that correlation does not always mean causation. That means that one variable could be correlated to the other variable. You could have a very strong linear correlation. However, that does not necessarily mean that one variable is causing another variable to change. The distance between an observed value from a scatter plot and the predicted value from the linear regression line is a residual. Positive residuals give the distance from a point above the linear regression line to the line, and negative residuals indicate that the point is below the linear regression line and it gives the distance from the point to the line. Residual plots that do not have patterns indicate that a linear regression model is a good fit for the data. And the sum of the residuals is 0. Let's take a look at this data in Desmos. So here I have the table already typed in. And to start with linear regression, I'll go to this entry bar and paying attention to my variables, since they are x1, y1, I'll type y1 tilde m x1 plus b. And here I have my slope and my y-intercept. I also see that my correlation coefficient is listed right here. It's -0.9531, which indicates that I have a strong negative correlation between variables. The other way that I could find the correlation coefficient, if I didn't want to do linear regression, is I could type in CORR and then type in my variable labels, x1, y1, and I'll get the same thing. For my residuals, I'm going to click this button right here to create a residual plot. And what this is telling me is that here, this point at 110, it is approximately 0.2 units above my linear regression line. This point right here, 2.9 from the table, is approximately -0.07 units below my linear regression line. This data right here is plotted right here. That color is hard to see, so I'm going to change it to purple so that you can tell the difference. Right here is my residual plot. I could also hide everything else, so I can just look at my residual plot. And it looks pretty random. So I think it's safe to say that since the correlation coefficient is close to -1, and I have a fairly random residual plot, that this linear regression model is a good fit for this data. All right, that's it for this video. Thank you for watching.